Hi, welcome back to revision for 2019. If you remember, we were looking at a question on our last section to do with pneumatics and hydraulics, and I wanted to take a separate video just to look at pneumatics and hydraulics in a little bit more detail. So that's what we're going to do with this session. Now the question that we're looking at deals with what is a 5-2 valve. What I want to do is I want to sort of take a step back and just look at how you look at these and how you translate these diagrams and how you understand them. So to do that, I just need to get set up. I'm going to give you a little model. So here's a model of a diagram, and we're going to look at 3-2 valves to start off with. So let me pause and then we'll get set up. Okay, so you can see here that I've got a diagram, and what I've done is I've tried to turn this into a moving diagram. I'm going to animate how these diagrams are actually understood, because it makes a little bit more sense for you to how to understand how this works. So what I've done is I've done a drawing of the 3-2-way valve and a single action cylinder. And I got this information from, and this is really worth going and checking out this website, www.bbc.co.uk, schools, GCSE bite size, design, systems control, pneumatics, rev1.shtml. It's really worth checking that out if you want to understand this in a little bit more detail. And they've got about 5 pages there. These diagrams look really complicated, and it's because you sort of see this section here that's not connected to anything. Well, actually, to understand these diagrams, you need to use your imagination, and you need to be able to visualize this part actually moving, because this and this are part of the valve. So here's how it works. This symbol here means air in. So there's air going into this tube here, and it's reaching this T block, so the air is not going anywhere. You can see here this spring is pushing back against this flat plate. This is inside a cylinder. It's a bit like a bicycle pump. So the air is able to pass out through here and to pass out through this exhaust port. So watch what happens when I press this button. So I press the button, this spring is compressed now, and now you can see that the air can enter through here and fill this chamber. So what now happens is the air fills this chamber, the spring is compressed, and you get what's called an outstroke. When I take my finger off the button, the air can now be compressed by this spring, so this spring extends out, pushes the air back through here and out through the exhaust port. So this is a 3-2 valve on a single action cylinder, and it's a single action because this cylinder just does the outstroke, and the spring automatically puts it back. So let's just illustrate that again. So I close the switch, air is pushed into that chamber, pushes against the spring, causes the actuator to outreach. Take your pressure off, air is allowed to exhaust out through the system, like so, and you get the actuator going back in. Okay, so now what we're going to do is have a look at the 5-2 valve. So we'll put this model out of the way and bring in our 5-2 valve. And again, this is, if you want to revise, this is a really good way of helping you revise and understand by actually building a model. So here's the model of the switch, and again this is on www.bbc.co.uk bite size. So I'll put that in the closed position, and I've actually created the inside of the cylinder so that this can slide up and down. And the reason for that is that this is a double action cylinder. And you'll note this because it's got 2 ports to allow the air to come in from either end. So let's have a look at this question again. So you can see they've given you here effectively only one part of the diagram. They've given you this section here, but with a little bit of knowledge you'll be able to decode that and understand the question. So let's look how this works. At the moment you can see that this chamber is allowed to exhaust out through here, and the air is going in and filling this part of the chamber here. So it's pushing, there's pressure in here pushing the cylinder that way. Okay, so it's stopped by the joint at this point here. So if I press the button, like so, the air going in can now pass up through here and start to fill this part of the cylinder. So this will then fill up and create an outreach. So you've got an outstroke going here, the air's coming in there, that chamber comes under pressure. Switch it back, air's going in this way, filling this part of the chamber, pushing the actuator back, the air is able to exhaust out through this port here. Okay, let's just do that again. So close the switch, air comes in, pressurizes the cylinder, forces the actuator out, release the switch, this air can exhaust, air pressure goes into this end of the chamber, the actuator is pushed back the other way. And that's how you understand these diagrams, by realizing that this part of the diagram moves and is brought into place. And if you can visualize that, then you can start to understand how a pneumatic or a hydraulic circuit works. So, why is it called a 5-2, or why is it called a 3-2? So, this is a 3-2. We have 3 ports. 1, 2, 3. Remember, this is part of the same components as 1, 2, 3. We've got an inlet. This port here, or this part of it here, that's the inlet port, that's port 1. And we have an outlet at the other end, this would be port 2. So I'll just number that 1, and that would be 2. So the inlet and the outlet. Here the inlet's blocked, and the outlet's coming the other way, but it's still the outlet port. And finally, port 3, the exhaust. Okay? So it's 1, 2, 3 the same, 1, 2, 3 the same. Remember, this just slides across. So it's got 3 ports. It's got 2 states. It's got closed, as it is now, and it has open, which is where this would be moved into position. So you've got 2 states. You've got 3 ports, and you have 2 states, open and closed. 5, well, if we look now, we've got 1, 2, 3, 4, 5 ports. So it's a very similar thing. You've got 5 ports, you've got your inlet port, 1, you've got your, and this is when it's closed state, or it's activated with the in-reach rather than the out-reach port, like so. So 1 to 2, like so. And this would exhaust, in that position, this would exhaust through 3. We have 1, 2, 3, like so. We have 4 and 5. And we have 2 states. We have air flowing through this way, state 1, or air flowing through this way, state 2. So that's a 5 two-way. And that's how they picked up their names. Another really good website that's got some product information that I found quite useful. https //tameson.co.uk product dash information HTML. And if you scroll down there, there are a few links that you can find that link to 5 two-ways and pressure gauges, and they give you some nice diagrams, and it's worth an opportunity to sort of look at and try and understand those diagrams to get a better idea of how pneumatics work. So let's have a quick look back at the question then. We were looking at this question. So we can explain what is meant by a 5-2, count the ports, 1, 2, 3, 4, there are 5 ports and there are 2 states. There is the state where the air is coming out, so that the stroke would be on the in, or the air can switch over to this side, this would exhaust, and air would go in the other end, because 5-2s are for double actuated cylinders. So what is meant by the 5-2? It has 5 ports and 2 states. Describe the operation of the valve when the valve is used to outstroke and actuate a piston. So right now we've got the air coming from the back of the cylinder, and it's probably worth being able to sketch a cylinder. Quite simple, just like we've seen, and then put 2 ports on it. Well, I want the air to go in here to push it back, and if I want an outstroke, then I want the air coming in that one. Well, right now I've got that, I've got the air coming in here, it goes to port 4, so again, think like an engineer, talk like an engineer. So I've got air coming in at 1, air in at port 1, activates the cylinder, causing an outstroke. But this also means that air is coming out of here and exhausting. Exhaust air travels through port 2 and out port 3. Okay, talk like an engineer, think like an engineer, use the vocabulary, and you'll be able to pick up the marks. It's saying add a label to the diagram in figure 6 to show the exhaust ports on the 5-2. That's one there, one there. State where the exhaust air is released to in a pneumatic system. Well, this is important to learn, so you need to learn this. Exhaust air can just be exhausted to air, it's just released to the atmosphere. So it doesn't go anywhere special, it's just a little hole in the side of the valve and the air just goes out into the room, if you will. And how that's different, if you read the next question, describe how this is different to a hydraulic system. You wouldn't just allow, hydraulic systems are fluid, hydro like water, so it contains an oil in fact. And you wouldn't release that just out into the room, it would just be all over the floor. So actually that gets recycled. It's sort of, oops, it stays in the system, so it will be exhausted, the oil would be exhausted out through a valve, but then it would be cycled back into a reservoir, and then the pump would pick that up and pump it back into the system, put it back under pressure. Well, I hope you found that useful, and hopefully you can maybe make yourself a couple of models to help you understand it a little bit better. But definitely check out BBC GCSE Bite Size, because there is really good, there's about 5 pages, and it's a really nice explanation of some basics and the symbology that you need to learn. I hope you found that useful.